All right, let's dive right in. We're about to take a journey to the absolute edge of reality, to a place where the universe as we know it, well, it kind of dissolves into something way, way deeper. A place where the very numbers we use to describe everything might just be an illusion. Welcome to the world of quantum field theory.
So at the very heart of modern physics, there's this incredibly elegant idea, quantum field theory. And what it's telling us is that everything you see around you, the chair you're in, the screen you're looking at, even you, isn't really a separate thing at all. Nope. Instead, reality is just one huge connected field. And everything in it, it's all just a ripple, a little flicker of energy in that one single field.
To put it another way, QFT is our best shot at describing what reality is at the most basic level possible. It's the fundamental rulebook. In this picture, particles aren't these tiny little billiard balls zipping around. They're much more like waves on a vast cosmic ocean.
And that's what is so beautiful about this idea. It ties together matter, energy, and all the forces into one single coherent story. It is an almost perfect theory, giving us this powerful, holistic picture of the cosmos. But almost is the really important word here.
Because underneath this gorgeous surface, there's a really deep, hidden problem. A little crack, right in the foundation of the whole thing.
So, let's just ask a kind of provocative question here. What if the very tools we're using to build this perfect theory, the numbers themselves, are actually flawed? What if the language physics is speaking is based on ideas that don't really exist in reality?
And that, right there, is the problem. QFT is written in the language of what we call real numbers. That's basically every number you can think of on a number line. Whole numbers, fractions, decimals that go on forever, the whole shebang. But as we're about to see, this system is built on surprisingly shaky ground when you push it to its limits. And this isn't just some weird math problem. It actually threatens the entire structure of the theory.
Okay, so to really get what's going on with real numbers, we've got to break them down into their parts. And we're going to start with the ones that seem the most solid, the most dependable, the rational numbers.
So the real number system is really made of two different types of numbers. On one side, you've got your rational numbers. These are the nice, neat ones you can write as a simple fraction, like 1/2 or 7/3. And on the other side, you've got the irrationals, things like pi or the square root of 2. Their decimals just go on forever and ever without repeating. And here's the crazy part. The problem for quantum field theory starts with the ones that seem so simple, the rationals.
This is such a strange and fascinating claim. It's suggesting that these simple fractions, these tiny little ratios, just break down at extreme scales. They actually stop being a meaningful way to describe the physical world.
So, what on earth could that mean? How can a mathematical idea just stop working? It's not that the concept of 1/2 suddenly vanishes, but its ability to actually describe something real might just hit a hard wall. And it turns out there are two pretty powerful physical reasons why this might happen. First, there's an information limit. So imagine a number with 1 billion digits in its fraction. That's a ton of information. Physics tells us there's a limit to how much information you can cram into any part of space. A number could literally get so complex that the universe just doesn't have enough RAM to process it. And second, there's the Planck scale crisis. If you zoom way, way down to the smallest scale imaginable, space-time itself is thought to become this chaotic, bubbling foam. I mean, how can you measure a precise fraction if the very ruler you're using is constantly churning and changing? The idea of a simple ratio just falls apart.
Okay, so rational numbers seem to fail at the extremes. But if that's a crack in the foundation, well, the problem with irrational numbers is a full-blown chasm. It's even more fundamental.
Now this is the really dramatic claim. It's not just that they break down, but that from a purely physical point of view, they were never real in the first place. That is a huge statement that pushes back against centuries of how we've thought about math.
So here's the 1-2 punch that makes the case. First, to even define an irrational number like pi, you have to specify its entire, infinitely long, non-repeating string of decimals. That's what it is. But, and this is the absolute killer, a completed infinite process is something that just cannot exist in the physical universe. You can't count to infinity. You can't store an infinite amount of data. So any object that needs a completed infinity just to be defined is, physically speaking, a complete fiction.
So if our numbers are flawed, if they're not really up to the task at the most fundamental level, then what's the alternative? Well, this forces us toward a completely radical and honestly beautiful new way of looking at the universe.
You know, maybe the problem isn't the numbers themselves, but our whole assumption about what they are. We've always kind of thought that mathematics is this perfect, timeless language that exists somewhere out there, and that the job of physics is just to figure out which equations to apply to the real world. But what if that's totally backwards? And this is the huge paradigm shift. It's the idea that the ultimate laws of physics don't use numbers, they actually create them. That there's some deeper layer to reality, and from its fundamental rules, the very mathematical structures we need to describe it just emerge.
It's a complete flip of how we see things. The old view was that physics uses math like it's a toolbox that was already there. This new view suggests that physics generates math. The rules aren't sitting in some perfect abstract realm waiting for us. They are born from the actual physics of our universe.
And the implications of this are just staggering. It means our job as scientists isn't to find the right pre-made mathematical suit to fit the universe into. Our job is to discover the fundamental generative rules that actually weave the fabric of reality itself, a fabric from which its own descriptive language, its own math, just naturally arises.
And so we end on this final, mind-bending thought. We started out seeing the universe as this unified field described by numbers, but we now face the incredible possibility that the universe is something even deeper, a system that generates its own rules, its own logic, its own numbers, a cosmos that isn't just playing by the rules in the book, but is actually writing the book as it goes.